And welcome back, and it is the 3rd of May, higher plus 5 a day. And let's just go straight to the first one. Okay, solve. Now, the important thing here is the word solve. So not just factorize or not just do something else, but actually make sure you get the answers x equals. Now, as ever, if you see my videos, I quite like to say, let's have a go at factorizing, because commonly with these Corbett maths videos, you can typically factorize what you're given. Not always in an exam, but I suspect you can here. So my usual rule, if this first video you've seen me say, is give it 2 minutes. If you can't spot it, just use a quadratic formula. You'll get there quicker, you'll get the right answer. Anyway, 5x is only going to be 5 and 1, so hence I can put 5x and x. I can see it's a negative 24, so it means one of these is going to be a negative, and I don't know which one. And then think about what the factors of 24 are. So there's 8 and 3, 6 and 4, 12 and 2, and 24 and 1. I'm guessing 6 and 4, and I know 5 times 4 is 20, and 20 minus 4 is 14, so I think it's going to be plus 4 and minus 6. Now, if this is the first video of mine you watched, you might be thinking, how did he do that? And the answer is, well, first of all, I've done it in many other videos, and secondly, it is just a bit of experience. So don't worry if you can't see it straight away. Don't worry if you do the sort of alternative algorithm method. Don't worry if you use the quadratic formula. All of these will get to the same answer, which is going to be that x is equal to 6 over 5, or x is equal to minus 4. And that is it. First question done. Not too bad today, not too bad a start. Next question. Find the nth term of. Now, we seem to get a lot of quadratic sequences here, and I'm guessing this is another one. So 5 to 8 is plus 3, 8 to 13 is plus 5, 13 to 20 is plus 7, and I'm guessing without even looking that's plus 9. So it is another quadratic. So the difference is plus 2, which means now my second difference is equal to 2, which means my a term is equal to 1. And what I mean by that is the nth term of a quadratic sequence is an squared plus bn plus c, and I know that value there is 1. You might know the 3a plus 1 and a plus b plus c method, and that is fine. If that works for you, no problem at all. But I quite like the idea of actually building it up and the method I'm about to do now. So there's my sequence. I'm going to take 1 lot of n squared because that number is 1. So n squared is 1 squared is 1, 2 squared is 4, 9, 16. And I'm going to take these away. So 5 minus 1 is 4. 8 minus 4 is 4. I've got 4 again. 13 minus 9 is 4. 20 minus 16 is 4. So in a weird way, this is actually quite a good example of where this method is a bit quicker. So therefore, it's going to be un is equal to, as discussed, 1 lot of n squared plus the 4 that's left over, which is my nth term. What does it want? Wants the nth term. That's it. Question done. Next question. Make B the subject of. So this is what's considered the hard version of the question because there's 2 B's. So I can't just inverse it or do it backwards. I need to do the algebra in between. So let's do that. So let's first of all start by squaring both sides. So that's going to give me 4ab over a minus b is equal to 25. That's fine. Square both sides. That's okay. Then what I'm going to do is bring up the denominator. So therefore 4ab equals 25a minus 25b. Okay, now let's remember what I'm doing. I want to end up with b equals. So I'm going to move my b's to the other side. So I've got 4ab plus 25b is equal to 25a. Then factorize out the b, so that's going to be 4a plus 25. Once you've done these a few times, you get very good at just doing the same process each time. And then I'm going to divide by the 4a plus 25, which tells me that b is equal to 25a over 4a plus 25. And that is question done. Not too bad. Next, and actually last question today. And it looks quite a horrible one. Okay, let's read this carefully. Bag 1 contains 3 red, 5 white and 2 green. Where can I write this? Let's write this down here. So bag 1 contains 3 red, 5 white and 2 green. Bag 2, God, there's 3 bags, this is not going to be easy, contains 2 red, 2 white and 3 green. Okay, so first of all, just to state the obvious, there's different numbers of reds and green in each bag, so this is going to be a bit more difficult than what it might otherwise be. And bag 3 contains 4 red, 1 white and 1 green. So let's just add these up. So 3 plus 5 plus 2 is 10 balls in that one, or counters or whatever they are. 2 plus 2 plus 3 is going to give me 7. So there's 7 over here. And there is 4 plus 1 plus 1, which is 6 in bag 3. Okay, I almost don't want to read the rest of the question, but let's have a go. A bead is taken from each bag. Right, so we're just taking 1 from each bag. A red is worth 1, a white is worth 2, a green is worth 3. I don't like where this is going. The points are added together, so remember I'm taking 1 from each bag. Find the probability of scoring 5. Okay, we need to start off by thinking how to get 3 beads that add up to 5. So that is going to be, well, it's going to be 2, 2 and 1, isn't it? So it's going to be 2, 2 and 1. But because there's a different amount of colours in each bag, it's going to be 2, 1 and 2, or 1, 2 and 2. Right, any more ways? I can also get 3, 1 and 1. So 3, so not 3, 3 and 1, 3, 1 and 1. So 3, 1 and 1, or 1, 3, 1, or what am I doing? 1, 1, 3. So there's 6 different ways of picking the counters from the bags that will give me a total of 5. Before I move on, that's correct, isn't it? So I can't do 2, 2, 2, 3, 3. Yep, that's it. Okay, happy. So just to make it really clear, I'm actually going to translate these to colours. So that's going to be white, white, red, white, red, white, and red, white, white, or green is 3, so that's going to be green, red, 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 green, red, or red, red, green. Now, this is going to be messy. What's really important here, which is the whole point of this question, by the way, is you need to recognise that a red from one bag is not the same as a red from another. So this is going to involve writing them all out carefully. So let's do that. So white, white, red is going to be, in that order, it's going to be 5 over 10 times red, white in the second one, which is going to be 2 over 7. Okay, and the video will have cut there and come back to me having filled in the whole table. So just to explain a line, just so you know what I've done. So for example, this line here, I've considered in order to get 5 points, I'm picking a red ball, 1 point, and then a white and a white, which are 2 points each, which gives me 5 in total, in that order. So the 3 out of 10 comes from the 3 red balls in bag 1, 2 out of 7 from the 2 white balls in bag 2, and 1 out of 6 from the one white ball in bag 3. Then I multiply all those probabilities together, which gives me 6 over 420. Then what I need to do is I need to add up all these probabilities. So it's going to be 40 plus 10 plus 6 plus 16 plus 36 plus 6. Note, all over the same denominator. I haven't simplified any fractions, otherwise that would make it really difficult. So I can just add all these up, which gives me 114 over 420. And if I do that on my calculator again, that simplifies down to 19 over 70. That's a tough question. It is definitely, especially if you do international GCSE, questions like this have appeared. Not this lengthy, not this difficult, but equally the combination of different ways of getting different values and putting them together has been a question before. Wow, today actually was pretty straightforward, wasn't it, until that last question. If you didn't get it, do add a comment and I'll still reply to it. But either way, pause the video, give it a go again, and just make sure you can get your head around that question. I've seen questions like that in exams. Either way, like, subscribe, do let me know how it went for you, and I'll see you tomorrow. Thanks all.